Hey guys, and welcome back. Today we are going to talk about naming ionic compounds and also learning how to figure out the formula of ionic compounds when there are polyatomic ions involved. So the naming part is going to be really easy, and then hopefully the polyatomics will be pretty straightforward as well. So just a reminder, ionic compounds are compounds of two or more elements where a metal cation is bonded with a nonmetal anion, and of course the overall charge of that compound is going to be neutral. Okay, so up to this point all you have had to do is take a look at a metal and a nonmetal and determine their charges, and then determine the compound formula based on the charges. Now we are going to have to be able to look at a formula and name the compound, or be given the name of a compound and then be able to determine the formula from it. Okay, so in order to do that, you're going to have to know how ionic compounds are named, and it's actually pretty easy. So when you're naming an ionic compound, you are going to write the metal first. So let's say the metal in your compound is lithium. You would literally just write the element lithium. So lithium goes first. Next, the nonmetal is the second word in the naming, and you would change the ending to IDE. So you would drop the ending of whatever compound or element it is, and instead of having the original ending, you would change it to IDE. So we use lithium as our metal. Let's use fluorine as our nonmetal, right? So fluorine is a nonmetal that could bond with lithium to make an ionic compound. And fluorine ends in INE. So what we would do is we would change the INE to IDE. So instead of having lithium fluorine, the name of the compound would be lithium fluoride. Okay? And that's it. So lithium fluoride would be the name of the ionic compound. Okay? And of course, you'll be able to determine these based on the elements that are in the compound. Okay, so let's do that with these two or a few examples. So here we have calcium as our cation and fluorine as our anion. So if we were going to name this according to the ionic compound naming rules, we would write our metal first, and then we would write our nonmetal, drop the ending, and change it to "ide." So I'm going to do that here. So our metal here is calcium. So we'll just write calcium. And then, of course, our nonmetal is fluorine. But we don't want the INE, right? Because this is not calcium fluorine. This is going to be calcium fluoride. So we're just going to change that INE to IDE. Okay, so the name of this would be calcium fluoride, right? Now, let's do another one. So we have magnesium and nitrogen here. So we're going to write our magnesium because the metal just is the name of the metal. Okay. And now nitrogen, we're going to drop the ending and we're going to change it to IDE. So this is going to be magnesium nitride. Okay. Magnesium nitride. So nitrogen, the ending gets dropped, and we replace it with IDE. Then, let's do one more. We have aluminum. And then this is phosphorus. So we are going to drop the end of phosphorus and change it to IDE. So this would be phosphide. Okay, so calcium fluoride, magnesium nitride, aluminum phosphide, and that is all you have to do for the naming of ionic compounds. And I just do want to clarify, since we've done those examples, these are with ionic bonds between one metal and a nonmetal. So there is going to be a little bit of a different naming rule for transition metals and polyatomics, which we'll talk about right now. And okay. So now let's talk about transition metals. So So far in the examples that we've done, we've been looking at the metals that are on the left-hand side of the table, but we've been skipping over to transition metals because remember, it's hard to determine the valence electrons of transition metals because they vary. So they're in that B group that's in the middle of the periodic table. So transition metals have varying charges. So in order for you to know what the charge of a transition metal is, it requires a Roman numeral. So an example here would be cobalt 2 chloride. So that's the name of the ionic compound. And this would mean that cobalt has a charge of positive 2, okay? Remember, the transition metals are still metals, so they're still going to donate their valence electrons, so the charge on the transitions will always be positive, okay? So all that's different between naming transition metals versus just a normal ionic compound is going to be that the transition metals get a Roman numeral to show the charge. So whatever the charge is on the Roman numeral or on the transition metal, it gets the Roman numerals in parentheses after. So if you see cobalt 2 chloride, we know the metal is cobalt, which is a transition metal. We know the charge is 2 plus because the transition metals will always have a plus charge. And then chloride, we know that IDE ends in an INE, so that would be chlorine. So this would be a cobalt with a 2 plus charge and then our chlorine as well. So that's the transition metals. Now we got to talk about polyatomic ions. So polyatomic ions are exactly what it sounds like. Poly means many or more than one. So a polyatomic ion is going to be an ion that has more than one element in it. Okay, so it's going to have more than one element. But the thing is when we're doing ionic compounds, we're going to treat these polyatomic ions as if they are one unit. So the multiple elements themselves will have a single charge on them. And I'll show you what I mean here in just a minute. So polyatomics act exactly like a regular ion, except it's made of more than one atom. So because it's a whole, we do not break it apart. Okay, so far we've only been dealing with 2 elements. Now it's going to get a little bit stickier. Now, here's the good thing about the polyatomic ions. You do not have to memorize them. You are going to copy a document into your Google Drive that has the common polyatomics, and all you have to do is be able to identify them on this table. Okay, so here we have some of the common ones that we'll be working with throughout this course. So if you see a polyatomic, you are just going to have to come to this table. And if you see the charges will be given to you from the table, right? So we know with the single elements, we find their charge from the periodic table, depending on what group they're in, what valence electron they have. But with polyatomics, you just look at the table. So let's say you have cyanide as one of your polyatomics. Well, cyanide, the overall charge of the polyatomic is a -1. So we're going to apply that charge to the entire thing. The way you can identify polyatomics, if you're given the formula, there's going to be at least two capital letters, if that makes sense. Because we know that an element either is a capital letter or a capital and a lowercase. So if you see like a nonmetal grouping in an ionic bond that has at least 2 capital letters, you know that it's a polyatomic and you're going to need to come identify it in your table. That's if you're given the formula. But polyatomics are also named differently as well. So if you're given the name of a compound, how do we know that a polyatomic ion is present? Well, normal anions end in IDE. So like calcium fluoride ends in IDE. You know you've got a calcium and you've got a fluorine and that's it. However, if you are given the name of a compound and it ends in ate or ite, then you would know it's polyatomic. So ate and ite, that would be your indication. You need to go to your table and figure out what the formula is for that polyatomic anion. So ate, ATE, ite, ITE, that's a polyatomic. If it ends in IDE, that means it's just a normal cation, anion, ionic bond. Now, an exception to this would be cyanide and hydroxide. Now, hydroxide you will see a lot. Hydroxide is just OH, and that's one you just really do need to memorize. And then cyanide is CN, so carbon and nitrogen. So just make sure you commit these two to memory, and then the rest, as long as you can differentiate between the ide, ate, and ite, you'll be golden, okay? And again, polyatomic ions have more than one capital letter to show us that there's more than one element in the ion. Okay, so go ahead and pause really quickly, and I want you to go through these examples and see if you can determine whether or not the following are polyatomic, just based on the name. So based on the name of the compound, are these polyatomic? And I'll give you just a minute to make sure the video is paused, and then once you resume, we'll go over them. Okay, so let's go through these. So the first one is zinc oxide. So we've got zinc and oxygen, and it ends in IDE, so that's going to be a no. That is not polyatomic. So the polyatomic poly many applies to the anion, so not the metal, but the anion. So there's only oxygen there, so he's one dude, not polyatomic. Next is sodium carbonate, ATE. Carbonate, it ends in an ATE. That's my indication that it is polyatomic because there's no ide at the end. So ATE is going to be, yes, that's polyatomic. Next we have nitrogen sulfide, again ending in IDE, which is going to be our indication that that is not polyatomic. That's just going to be nitrogen and sulfur. Also, nitrogen and sulfur are two non-metals, so that wouldn't even be ionic. I'm not sure why that example's up there, so don't even worry about it. 4 is lithium sulfite. ITE ends in not IDE, so it's an ite, which means that is a polyatomic. Magnesium cyanide, it ends in IDE, but remember that cyanide is an exception, so that is a polyatomic. And then potassium hydroxide, again, ending in IDE, but it's hydroxide, so that's one of the examples. So it is polyatomic. So again, it would be no, yes, no, yes, yes, and yes. All right, so then how do you write the formulas for polyatomic ions? It's going to be very similar to the way that we did the formulas for the regular ionic compounds. It's just instead of treating the polyatomics as separate elements, you're going to treat them as one group with the charge applying to the whole group. So let's take the example magnesium bromate. We know that this is going to be a polyatomic because he ends in ATE. So our metal here is going to be magnesium, and our polyatomic anion is going to be bromate. So we're going to separate it into ions first. We're going to use our periodic table to figure out the charge of magnesium, and then we will use that common polyatomic ions to figure out the charge for bromate. We're going to put parentheses around the polyatomic. We're not going to do anything inside the parentheses because the polyatomics act as one. And then, just like we did before, we're going to swap, drop, and chop those charges. So let me do this one right here. So magnesium, we know is going to be 2+ because he has 2 valence electrons. So let me get a drawing. So magnesium will be Mg, G, 2+. And then bromate, we're going to have to find on, oops, I have to get that back in just a minute. Bromate, we're going to have to find on our polyatomic ion. So we'll come here and find bromate. Let's see where he is. Bromate, right here. So bromate is BO3, 3-. So the charge is 3-. So let's come back here and do this one again. So bromate is BO3, 2-, and then magnesium is Mg, 2+. Okay, now remember, you have to be able to find the charge of magnesium on your own because we know that magnesium is an alkaline earth metal. It's in group 2. It's got 2 valence electrons. Therefore, it's going to donate those electrons and become 2+. If you don't know where that charge came from, you need to go back and do those first 2 lessons again, because I need you to be able to figure out the charge of the cation in order to be able to be successful with this.